Let's look at final exam question number 14 in Physics Demystified, 2nd edition. If you have the printed book, you'll find it on page 515 along with figure exam-2, which I have reproduced here in somewhat simplified but color-enhanced form. This graph shows time in seconds from 0 to 10 and speed in meters per second from 0 to 10. And then we have a graph that looks like this. The question reads, Figure exam-2 graphically portrays the instantaneous speed of an object traveling in a straight line path as a function of time. What can we say about the acceleration magnitude as a function of time? Well, acceleration magnitude is just the numerical extent of the acceleration. We're not worried about what direction it's going in because the object is moving in a straight line, so the acceleration and the speed vectors all point in the same straight line, as does the displacement vector. It's much simpler than if the object were going all over the place. It's just traveling in a straight line. So we're talking about acceleration magnitude, and this is the speed. Well, acceleration, when you have a graph of speed versus time like this, the acceleration at any given point in time, like this, like this, like this, is the slope of that curve. We can see that it starts out pretty steep, gets shallower and shallower. So the correct choice here is A. The object starts out accelerating rapidly, and as time passes, its instantaneous rate of acceleration decreases. The object does keep moving faster and faster, but it speeds up at a decreasing rate as time passes. So the correct choice here is A. Let's look at these other choices and just see what those curves would look like. Choice B, the object starts out accelerating slowly, and as time passes its acceleration rate increases. Well, that would give us a curve that would look like that. Choice C, the object accelerates at a constant slow rate. Well, that would give us a straight line with a shallow slope like that. The acceleration, the slope, would remain constant even though the speed would increase. D, the object accelerates at a constant rapid rate. Then we get something like that. A straight line with a steep slope. The speed would increase rapidly but at a constant rate. Now E is interesting. The object starts out accelerating forward at a decreasing rate. So we get something like this, like the same curve that we've got here. Then it comes to a complete halt. The speed would drop right down to 0. There'd be a tremendous jerk. The people on board a train, say, traveling at a speed like this and then stopping suddenly like that, tremendous jerk. They'd be thrown forward with a tremendous amount of force. Horrible experience. Then comes to a complete halt and then begins accelerating backward at an increasing rate. Well, then our curve would go down like that. Backward speed would be negative speed in a graph like this. So our curve would look like that. Again, a pretty rough experience right there. By the way, when we have a rate of change of acceleration, that is a sudden increase or decrease in acceleration, we call that jerk. Jerk. So speed The change in the speed of an object is acceleration, and a change in the acceleration is jerk. So here we've got a gradually decreasing jerk. But right here, anybody unfortunate enough to be on this train, a really big jerk right there. Anyway, again, the correct choice in this question is A.